Selamat pagi, Ibu Dr. Anisah serta peserta dari GLS. Halo, selamat pagi Ibu Dr. Anisah. Selamat pagi Ibu Anisah dan Ibu Ajeng. Mohon maaf Bu, ini kesalahan teknis di Zoom jadi belum terbuka-buka dari tadi. Saya dari 8:30 buka tadi, jam waktu Indonesia bagian Barat. Jadi biasanya 1 jam sebelumnya saya udah ready gitu. Jadi mohon maaf sekali Ibu udah lama nunggu juga. Ini udah terlambat ya 13 menit dan 15 menit ya. Gimana Ibu Ajeng? Bisa dimulai Ibu Ajeng?
Boleh Pak, dipersilahkan Pak Wi
Oke.
and Dr. Anisah.
Oh ya. Selamat pagi. Mungkin menjelang siang ya, Bu. Menjelang siang. Ibu Dr. Anisah Abdul Rahman. Pertama saya memperkenalkan dulu kurung VT Ibu, yaitu Ibu Anisah binti Abdul Rahman sebagai dosen di Faculty of Computer Science and Mathematics Science, yaitu University Teknologi Mara, Cawangan Perak, Kampus Tapah, Malaysia.
Ya.
Education-nya adalah Master of Science in Mathematics, University Science Malaysia 2009, Bachelor of Science in Management Mathematics, University Teknologi Mara tahun 2006, Diplom in Actuarial Science, University Teknologi Mara 2003. Experience beliau adalah koordinator diplom in mathematical in science, yaitu di FSKM University Teknologi Malaysia Cawangan Perak 2013 sampai 2018, kemudian di Fakultas Sains FSKM University Teknologi Malaysia Shah Alam 2006 sampai 2007. Beliau pernah juri and reviewer paper ya, banyak tempat gitu ya. Itu tahun 2001 dari tahun 2019 sampai 2022. Kemudian publication beliau lumayan banyak ya. Kemudian community service, science to action, AZ match, program IPT bersama masyarakat mengubah destiny anak bangsa ke seluruh negeri Perak. Program jaringan dan jalinan SKK Universitas Teknologi Malaysia Bengkel Maple and Eksplorasi Matematik. Program operasi khidmat masyarakat Kampung Tonggang. Kemudian research grant, beliau pernah dapat dari grant dana kecemerlangan Rp3.090. Honor sebagai awardnya beliau pernah mendapatkan award yaitu Anugerah Perkhidmatan Cemerlang tahun 2012, Anugerah Perkhidmatan Cemerlang tahun 2017, Anugerah Persyarah Cemerlang yaitu khidmat masyarakat. Ini kurikulum vitae yang pernah beliau tuliskan gitu. Mohon maaf saya menggunakan bahasa Indonesia ya Bu.
Boleh.
Bu Anisah. Bahasa
Bisa.
Inggris kurang. Oke. Dipersilakan Bu untuk
Nggak
memberikan
apa-apa, Pak.
sharing knowledge-nya.
Lagi
Terima
pula kan
kasih.
bahasa Malaysia kan hampir identik dengan bahasa Indonesia.
Ya, hanya sedikit
Jadi
perbedaan.
Bapak tidak
ya.
perlu khawatir.
Ya, ya mirip sekali memang. Induk bahasa yang sama.
Iya.
Melayu, duanya Melayu Bapak.
Iya betul Bu.
Saya paham, saya paham.
Saya persilakan Ibu Dr. Anisah bin Abdul Rahman untuk memberikan sharing ilmu matematiknya.
Oke.
Terima kasih.
Terima
Saya tutup
kasih
dulu ya.
Pak
Oh, ya.
Zakaria. Boleh saya mulakan ya?
Boleh share Bu.
Ya, sekejap.
Pak, boleh saya rekam ini?
Ibu Ajeng dari
Iya Pak.
ditanya oleh Ibu Anisah boleh direkam.
You can record it or we can share the recording to you, Dr. Anisah.
Mungkin maksudnya ini Bu, rekamannya nanti saya yang kirim ke Ibu nanti. Saya sini.
Boleh.
Kena
Boleh,
rekamannya boleh ya Bu.
Sudah direkodkan, saya boleh mula ya?
Ya, silakan Bu.
Maksudnya, soalnya nanti untuk saya belajar ini.
Oh, yang lain ya kalau mahasiswa nanti saya share. Sabar aja ya untuk mahasiswa. Oke.
Boleh ya, saya
Bu.
boleh.
Ya.
Okay. Alright. Good morning to everyone. My name is Anisah binti Abdul Rahman. So today's would be the. Bisa ya saya cakap bahasa Inggeris? Oh, nak cakap bahasa Melayu?
Ya, silakan Bu.
Boleh ya?
Boleh Bu.
Alright. Boleh for today's class, for today's sharing session. This is just a sharing session whereby I just want to explain back on the topic that we're going to discuss would be what would be the usefulness of substitution rule in calculus, which is we're going to focus on integration by substitution. So as you know, whenever we want to integrate a function, there will be two techniques to integrate the complex function, which is the first method is integration by substitution, and another one would be the integration by parts. So we only focus on integration by substitution for this sharing session. Now, when we say about integration by substitution, so normally we will know as the U-sub method, we can call it as the U-sub method, or we can say it would be the reverse change rule. All right, I'm going to explain first on what does mean by the integration by substitution. So you can see here, integration by substitution is known as a U substitution, or we can say as the reverse chain rule, which is this would be a method to find an integral, but only when it can be set up in a special way. So the idea of integration by substitution is we want to perform a change of variable in order to transform a complicated function, a complex function, into one which is simpler to integrate. So sometimes when you are given a function, a complex function, you cannot directly integrate the function. Okay, so other way around, we're going to apply this method to transform the complex function into the simpler one. So by using new substitution, it is easier to read and simplify the composite function, which can otherwise looks messy and intimidating. And the idea of doing U substitution is to rewrite the integral into a form that is easily fits with the known rules of integral. Okay, now before we look on how we want to solve the questions that involve this method, you should know first, what is the usefulness of integrations by substitution? So you can see here that The method of integration by substitution is extremely useful when we make a substitution for a function whose derivative is also present in the integral. So by doing so, the function simplifies and the basic formulas of integration can be used to integrate the function. And why substitution rules is important in calculus? We can say that we know that substitution rules is a technique or rule applied for integrating complex function. So by solving integrals using the fundamental theorem of calculus, it's not easy for all complex function. So it becomes challenging to find the antiderivative of a complex function. So in such cases, by applying this substitution rule, it will make easier for you to integrate the function. Okay, so that's why you need to know about the integration by substitution, because it helps you to transform from the complex function into the easier one, so that you can, once you have transformed it, you can integrate the functions easily. So it will help you to integrate the complex function. Okay, I'm going to share questions that we're going to discuss on today's discussion. No, this one. All right, so before we start integrate the functions using a U-sub method, so we look first on the definition substitution in indefinite integral. In substitution method, I will say the U-sub method lah. Okay, to apply the U substitution, there are two types whereby you will integrate for indefinite integral. Indefinite integrals, it means that the integration has no limit, and another one would be definite integrals. So we focus first on the indefinite integral. So it says here that let G be a function, let G be a differentiable function, and suppose that capital F would be the antiderivative of F. Then if you have U equals to Gx, the integration of F Gx G prime X dx is equivalent to integrate Fu du, which is you get the antiderivative of the function. So meaning that normally when we want to integrate the complex function, you will give it in terms of this form. Integrate fx, integrate, you will be given in terms of a function, and it will be in terms of dx. So from there, you will let u equals to gx, and then find the derivative of the function, which is the derivative of the function is you need to find the g prime x. And from here, you're going to substitute from the given function and transform from fgx g prime x dx. You will transform into this form, integrate fu du. And then this one would be, we said that integrate in a simple function. And once you integrate the functions, you will get the capital Fu, which is the antiderivative of the function. And since this is the indefinite integral, it doesn't have a limit, so you add a constancy. And once you have substitute, we're going to replace back the u that you have let into the function, and this would be the answer. So to integrate the complex function, there would be a step for you to apply so that you will know what would be the step to integrate the function one by one. So what are the steps in solving what is the step in solving integration by substitution? So first thing first, the first step would be from the given function, you're gonna choose a new variable u. So normally we write as let u equals to something lah, a given function there. And once you have let u, step number 2 would be you need to determine what would be the value of dx. So meaning that from u, you need to find the derivative, which is you need to find what would be the du over dx. And the derivative of the functions, you're going to rearrange this equation. You're going to bring the dx on the, let's say you have the statement du dx. So the dx here would be the term that you want to find what would be the value of dx, which is you have to rearrange the function so that you get the dx term. And step number 3 would be you substitute, step number 3 would be you make the substitution. Make the substitution would be from the integration of fx dx, you will transform into the integration of fu du. And this one would be the integrate the function into the simpler one, and integrate that one, you're going to have fu plus c, and then the last answer would be return to the initial variable x, which is you replace back the u that you have left on the first step into the function. Then you will get the answer lah, which is this would be the function of fx. So there would be a 5-step for you to apply whenever you want to integrate the function. Okay, next will be, I'm going to show to you a few steps whenever we want to integrate the complex function into the simpler one. So let's say on example 1 here, you need to integrate the 1 plus 3x to the power of 4 dx. Okay, this one, to start with of the integrations, normally to apply the integration by substitution, which is you want to let u, normally the given u, it consists in terms of a bracket. How you want to identify the u, normally it will be located in the functions that are located in the bracket. So for this one, this is just a direct function because it's not too complicated. You only have one function here with the power of 4. So functions that have in the bracket, you denote as a u, which is we let u equals to 1 plus 3x. From here, you need to find the derivative of the function, which is the derivative of the function. The derivative of the function will be you differentiate 1, you get 0, and you differentiate 3x, you get 3. So here, du over dx is equals to 3. So in step number 2, what you need to do, you need to find what would be the dx. So from here, we rearrange. First thing first, I bring the dx on the right side. So we get du equals to 3 dx. And in order for you to get dx, I'm going to bring 3 on the left side so that you get du over 3 equals to dx. So this is step number 2. Next, on step number 3 would be you're going to replace back from the original function with the functions of fu du. So write down back the given function, which is the integration of 1 plus 3x to the power of 4 dx. It is equivalent with the 1 plus 3x here, you have let as u. So this would be u to the power of 4, which is you get this one. And the dx would be the du over 3, which is you get on the step number 2. So dx here is would be the du over 3. Okay, so from the integration of fx dx, now you have transformed to the simple one, which is you get the integration of fu du. Okay, the next step would be you can see here that you have the a constant here, 3 here. So we take out the constant before you integrate the function, so that it will be much easier for you to integrate the function. So now we have here 1 over 3 integrate u to the power of 4 du. And you can see here that to integrate the function, it is much easier for you, which is you get here how to integrate u to the power of 4 du. Okay, lebih senang lah untuk kamu integrate the function. Okay, so this is what be into the simpler form that you have transformed from the complicated one. So once you have at this state, what would be, you just integrate the function, integrate u to the power of 4, you will have u to the power of 5 over 5. And since this is the indefinite integral, so you will out with the constancy. Okay, doing the integration, this is constant and constant, kita boleh keluarkan lah. You can just multiply 1 over 3 times with 1 over 5, which is you get this one. You should get u to the power of 5 over 15 plus with c. And as I said, on the final answer would be you're going to replace back the u, which is we have let at the first place. Okay, so kita gantikan semula lah the u here, and you're going to get the final answer would be 1 plus 3x to the power of 5 over 15 plus with c. So there would be the 5 steps that you're going to apply whenever you are given the complex function. Alright, boleh setakat ni? Is it clear on my explanation how we want to solve this one? Boleh, eh? All right, the next one I'm going to show to you on example number 2, how we want to solve this function would be complicated sikit lah compared to the previous ones. Okay, on example number 2 here, you need to integrate the x squared and the square root of 4 plus x dx. Okay, before you want to integrate the function, when you look on this given function, you know that you cannot integrate directly. So somehow you have to modify and apply the substitution method to solve this integral. Now, when you are given into a complex one, what you need to do, if you are given any roots, okay, so we have here the square root of here, so you're going to change, you can change the root into the power of the function, which is kita tukarkan punca kuasa kepada kuasa. So this function will become the integration of x squared multiplied by 4 plus x to the power of half dx. Okay, then first step would be you're going to let u, as I said normally, to identify the u, you need to choose a right function for u. So macam mana nak tahu kamu pilih u yang betul? Whenever you choose a u, you differentiate the function, you can substitute back into the function. If you cannot substitute back into the function, it means that the u that you have choose will be the wrong one. Okay, saya tunjukkan dulu. I'm showing to you first. If you choose the right functions. Is there any questions that you want to ask? I can see a notification here.
Where do I can't find u, Miss? U for like 4 plus x. Where can I find u?
Oh, okay. Now, as I said, to identify the u, in this question, there will be two possible of u that you can let. The first one would be maybe an x squared, or another one would be maybe a function in a bracket. Okay, and as I said, to let a u, it should be the right u that you should use. So I'm going to show you the first u that I choose first. Let's say if I choose let u equals to x squared, and then second step will be you have to find the dx, which is you have to find first what would be the derivative of the function du over dx. So if I differentiate dx squared, I'm going to get 2x. And then I need to rearrange, so I get in terms of dx. So dx I bring on the right side. So I get du equals to 2x dx. And then these two, I'm going to bring on the left side, which is I get du over 2, which is equals to x dx. So the third step would be, I should replace back from the integration of x squared 4 plus x dx, I can transform into integration of fu du. But in this case, when I want to transform into the integration of fu du, I cannot transform it because here we have the x squared dx, and here we have the x dx. It doesn't suit with the if I let u, you know that this would be the u, and then I still have here the square root of 4 plus x, and here to get the dx, we still have sorry, yang ni.
I mean, what's wrong by using x squared for u?
You cannot transform it back into when you want to change the function in terms of fu du, you cannot transform it into fu du because it still have a variable of x here. So same goes on this one on dx. If you want to get dx here, you still have a variable of x here. It means that you cannot, dx is not equals to du over 2. I mean, you cannot transform all with fu du. So when you cannot transform all with the function of fu du, it means that you have choose the wrong function, the wrong u. Okay, once you have choose the right u, you should be able to transform into all a variable u and du. Is it clear for you?
Still not clear. Still not clear.
Still not clear. Okay, I'm showing to you first the right u that you should choose so that you can clear what would be what u that you should choose whenever you want to change into the functions of fu du. So let's say, as I said, to choose a u, normally it's much easier for you to have in the brackets. We're going to transform the square root into a power of half. So the functions that consist in the bracket, we assign as a u. Okay, from here, once we have let you differentiate the function. Differentiate the function means that you want to find what would be the du over dx. Okay, differentiate a constant, you get 0. Differentiate an x, you get 1. So we have here du over dx equals to 1. And then dx, we bring on the right side. So we have du equals to dx. So settle on step 1 and step number 2. Okay, then the third step would be you're gonna change from fx dx to integrate fu du. Now write back the given question, which is integrate x squared multiply by 4 plus x to the power of half dx. Now, first I'm gonna change here first. 4 plus x to the power of half. We have 4 plus x is a u. And then power of half here is here. And then du would be equals to dx, means that dx here, we're going to replace with du. And then you still have a remaining of x squared here. Now, how you want to change all with the variable of u? We're going to move back on step number 1, rearrange the function. Instead of u, get the x term, means that what would be the value of x. So from here, you know that x is equivalent to u minus 4. And to get the x squared, it means that you have to get the x squared, it means that you have to square the function. So you have here u minus 4 squared. Expand the function, it means that you have to bracket u minus 4 multiplied by u minus 4. So expand it. So you're going to get u squared minus 4u, which is 8u, minus 14 multiplied by minus 14 plus 16. So this one, you're going to replace with the x squared. You get this one. Okay, so the integration of x squared, 4 plus x to the power of half dx, now becomes the integration of u squared minus 8u plus 16 multiplied by u to the power of half du. So now you can transform the complex function one here all with the integration of fu du. So if you manage to do so, if you manage to transform the function into this one, it means that you are choosing the right u. Compared to the previous one, when you choose as the x squared, you cannot transform into fu du. Is it clear? Is it clear at the moment?
Wait.
Then from here,
excuse me.
yeah.
You mean 4 square? It's where's you mean 4? Where's u minus 4 comes from?
From rearrange the function. From here, this is u equals to 4 plus x. If you want to get the x term, which is x equals to, we're going to bring 4 to the left side. So you get u minus 4.
Okay.
You just rearrange this one and make x as a term. It means that 4 you bring on the left side, so you get u equals to, x equals to u minus 4.
And where it's squared 2 comes from?
Here, from the given function,
Sorry.
from the given function, it's stated here this would be the x squared. So you have to rearrange the function. Once we get the x, if the given function want the x squared, it means that you have to square the function. So if you want to get the x square, it means that you have to square the function. So it means that you have to expand the function. You have to expand u minus 4 square. It means that you have to expand the function. It has two factor, u minus 4 and u minus 4. So expand it. U times u, you get u square. U times negative 4 minus 4u. Negative 4 times with u, negative 4u. And negative 4 times with negative 4 plus 16. So this is the same variable, negative 4u and negative 4u. You have u square minus 8u plus 16.
Oh, makes
So the
sense.
one, sorry?
Oh, makes sense.
Huh?
Oh, that makes sense.
Oh, that's okay. So this one, the x square that you have find here, you're gonna replace on this x square here, which is this one. You're gonna replace with this one. Okay, did you get it?
Okay.
Okay, then on the first step, you have let this one 4 plus x as a u. So this would be the u here. And we have here a power of half here. So you write down as u to the power of half. This one. And what would be the dx? Dx is the du. Okay, so the next step would be you have to expand first. You have to expand first by multiply u square with the u to the power of half, and then negative 8u with u to the power of half, and 16 with u to the power of half before you integrate the function. Okay, u to the power u square multiply with u to the power of half, you will have u to the power of 5/2. Okay, u kuasa 2 times dengan u kuasa setengah. The base is the same. So for the power, using the powers of rule, kuasa dia akan jadi tambah lah. So you get u to the power of 5/2. And then negative 8u times with u to the power of half. This is u to the power of 1 times with u to the power of half. You're going to get 8u to the power of 3/2. And 16 multiplied by u to the power of half. You're going to get 16 u to the power of half du. Just expand the function. Okay, next step would be, once you have expand it, then you should integrate the function. So integrate, if you have u to the power of n, it will become u to the power of n plus 1 over n plus 1. So this one should be u to the power of 5/2 plus 1 over 5/2 plus 1. So u to the power of 5/2 plus 1 is become u to the power of 7/2 divided by 7/2, which is, you get this one. So integrate one by one. So integrate negative 8u to the power of 3/5. We're going to get 8u to the power of 5/2 over 5/2. And integrate 16u to the power of half. You're going to get 16u to the power of 3/2 over 3/2. Okay, this process would be you have integrate the function. So the next one you can see here, this one you get a fraction by fraction. So you bring this fraction to the upward. Bawa naik ke atas. This one you bring here. So bila buat atas, dia akan jadi divide 2/7 will be multiplied by 2/7. So we have here 2/7 u to the power of 7/2 minus 2 over 5 times with 8, you're going to get 16 over 5, u to the power of 5 over 2. And then 2 over 3 times with 16, you get 32 over 3, u to the power of 3 over 2. Since this is indefinite integral, so you will add up with a constant c. And the last answer would be, you're going to replace the u with the functions that you have like before this, which is the 4 plus x. So on step number 5 will be 2 over 7, 4 plus x to the power of 7 over 2 minus 16 over 5, 4 plus x to the power of 5 over 2 plus 32 over 3, 4 plus x to the power of 3 over 2 plus with c. So this will be the answer for this integration. Are there any questions that you want to ask?
No, Miss.
Clear, yeah? All right, I'm going to move on the next example so that you can understand better on this technique. Okay, on this example 3, let's say you need to integrate the x over cos square x square dx. Now, as I said, to integrate the functions, normally you should choose the right u in the given function. And as I said, normally to choose a u, it will be somewhere, some functions that consist will be, the clue will be a functions that consist in a bracket 1. So to choose is either x or x squared. But a big hint whenever you want to integrate a function will be, normally it consists in a bracket. So let's say we choose u as an x squared. And then differentiate the u would be, you find what would be the du over dx. Differentiate x squared, you have 2x here. And then I'm going to bring dx on the right side. So you get the du equals to 2x dx. And from here, I'm looking back on the given function d as if here, you have here x dx is one term. And this one, we have x dx. So it means that I'm going to bring 2 on the left side, which is I got du over 2 equals to x dx, this one. I modified this one so that once I'm substitute back, I can get back in terms of fu du. Okay, once I settle on the step number 2, the next step would be, we're going to replace back the given function. So the integration of x over cos square x squared dx, it will become okay, the integration of the given function is this one. Okay, before you want to change, you can see that you have here as a cos square x squared dx, which is first step, I move to the right side so that you can see clearly that x dx will be the du over 2. So you become on this step. Before you want to integrate the functions, you cannot see that you cannot integrate cos squared. When you want to replace back, you cannot integrate cos square u. So what you need to do would be 1 over cos square is also is equals with, if we have 1 over cos, let's see, 1 over cos x, it is equivalent, a fraction, a rational function 1 over cos x is equivalent to second of x. So we have 1 over cos square x, it is equivalent to second square x. So from 1 over cos square here, I change into second square. So why we need to change into second square? Because you know that whenever you integrate second square x, you're going to get tangent x. Okay, so from equation of 1 over cos square x dx, I transform the function so that the equations will become integrate second square x square dx. So at this stage, then you should move on step number 3, which is we're going to change the u that you have let into the simpler one lah, which is second square x dx will become second square, still remain x square, the u that you have let on the first place, and the remaining x dx here, it will be the du over 2, this one. Okay, now you have transformed the given function into the simpler one. And then at this stage, you know that you have a constant 2 here. So do not interrupt with the integration process. You can take out the constant outside from the integration. So that it becomes 1 over 2, integrate second u du. And by right, you should know that whenever you integrate second square, you're going to get tangent. So since this is in the given variable of u, so integrate second square u, it will become tangent u. So integrate the indefinite integral, you should add with the constant c, and the answer should be 1 over 2 tangent u plus c, and the final answer will be you replace back the u that you have let just now, which is the x square. So the final answer would be 1 over 2 tangent x square plus c. This would be the answer. All right, is it clear? Any questions that you want to ask on this question? I believe that you understand. Okay, now to make sure that you understand on what we have discussed before this, let us do some exercises in order for you to understand better on this topic. Okay, on the first question, let's say you need to integrate the fx over 3x squared minus 1 dx. And from this one, you know that you cannot integrate directly. You should apply the integration by substitution. So first step would be you need to choose the u, which is you need to let u. So from this given function, which u you should let? We have two options here. It's either on this one or the functions in denominator. So what would be the u that you want to choose? You want? What would be the u that you gonna let? Is on a function which is on denominator or a function is numerator? Which is to make sure that you clearly understand on the choosing u. Okay, let's say normally a hint of u that you choose, normally it will, is either in the bracket or normally it will be located on the denominator. So let u equals to 3x squared minus 1. Step number 2 will be differentiate the u, which is you get du over dx. So differentiate 3x squared, you're going to get 6x. Differentiate -1, you get 0. So the next step would be, I'm going to bring dx on the right side. Du equals to 6x dx. And I try to rearrange so that on the given function, you only have x dx on the left side, which is I'm going to bring 6 to the left side. So here I get du over 6 equals to x dx. Okay, step number 3 would be from the given function, integrate fx over 3x squared minus 1 dx. I'm going to transform to the integration of fu du. So from here, you know that the x here, x dx here, this would be the du over 6. So we have here 4 over this one you have let as a u. So it should be 4 over u times with dx dx here, it would be du over 6. And we have a constant 4 over 6. You can take out from the integration. 4 over 6 integrate 1 over u du. 4 over 6 you can simplify, becomes 2 over 3, integrate 1 over u du. If you integrate 1 over u, what should you get? When you integrate 1 over u, what would be the value of that integration? Integrate 1 over u. What would be the integration of 1 over u here?
Ln u.
It should be ln u. So this would be 2 over 3 ln u. And since this is the indefinite integral, you add up with the constant c. So the last final answer would be going to replace back the u that you have left, which is, the answer would be 2 over 3 ln 3x squared plus 3x squared minus 1 plus c. So this would be the answer for this integration. Now, when you choose, it means that when you choose the right u, you can transform the integration into the simpler one, like this. And you, after that, once it's changed into the simpler one, you can integrate the function directly. Okay, now I'm going to show to you if I choose the wrong u. If I choose the wrong u, maybe you choose u as the 4x. Okay, in this one, we let u equals to 4x. Step number 1. Step number 2, we want to find the du over dx. Integrate 4x, you get 4. So du equals to 4 dx. And in order for you to get the dx, you should have du over 4 equals to dx. Okay, when I want to transform from the given function, it should be integrate. This would be the u that you have left. And then dx here would be times with du over 4. But you still have here the 3x squared minus 1. It means that in this integration, still pending with this one. What should you do with this one? You cannot transform all the function into fu du. So you start on at this stage. What you're going to do with this 3x squared plus 1, because this one you have let u equals to this one. And if you want to modify it, or if you want to modify it in terms of x, you're going to have u minus 4. So this one becomes u over 3 u minus 4 square minus 1 times with du minus 4. You have to expand it. You have to simplify it. It means that the process is still the law and you don't know whether you can solve it or not. So it shows that that would be the wrong u that you choose for integrate the function. So whenever you choose a u, it should be, it is easier for you to integrate the function. That is the key whenever you want to integrate, whenever you want to choose the correct u. And as I said again, normally on choosing a u, it will be stated is either on the denominator or either in the bracket of the function. Boleh? Okay, we're gonna move on. Second question, on question B. Let's say you have this trigonometric function and you need to integrate the sine to x multiplied by cos 2x minus 1 to the power of 3. So to solve this one, definitely you're going to apply the integration by substitution. So first step would be, you're going to let u, as I said, normally it's either u will located on denominator of the functions or u will be some of functions will consist in the bracket function. So in this case would be, we let u of functions that consist in the bracket, which is cos 2x minus 1. And differentiate the function, finding the du over dx. Differentiate cos 2x, what would be the value? If you differentiate cos 2x, be the value for cos 2x. Anyone?
Minus sign.
Right, what is minus sign? Differentiate cos, you get negative minus sign. So you have here minus sine 2x. And since you have 2x here, you should differentiate again with 2x, which is you get 2. So the du over dx would be negative 2 sine 2x. This is the du over dx. Okay, then from here, I'm gonna bring the dx on the right side. So I got du equals to negative 2 sine 2x dx. And then on this stage, I'm going to rearrange so that you can see here from this integration, if I rearrange the position, it should be cos 2x minus 1 cubed sine 2x dx. And here we have sine 2x dx. So it means that it should be sine 2x dx here. Meaning that negative 2, I'm going to bring on the left side. so that I get negative du over 2 equals with sine 2x dx. The next process would be we're going to replace back from the given function here with the integration of fu du. So it should transform with cos 2x minus 1 is the u that you have left just now. Here we have u to the power of 3. And sine 2x dx, it would be multiplied by negative du over 2. Now you have transformed into the simple one. Yes, Garibaldi, Britain, you have any question that you want to ask?
How minus 1 on how minus 1 of b change into 2?
Sorry, I cannot hear the question. Again?
How minus 1 becomes 2 in section B?
4 minus which one? 4?
Cos
B.
2x minus 1. How the minus 1 becomes
Oh, this one is a constant. When you differentiate a constant, it becomes 0. So I don't write here. So by right, when you differentiate, this one should be negative sine 2x multiplied by 2 minus 0.
Okay.
Okay, if you differentiate a constant, you get 0. So here,
and why is minus sin to x must be multiplied with 2?
because you have whenever you differentiate a trigo, whenever this is not a single x, you have a 2x. So to differentiate cos, you know you will get negative sign. And the given function on this trigo will be 2x. It means you have to differentiate again on what is the given function here. So a normal procedure would be, you know, if you have y equals to sine x, whenever you differentiate the function, you are finding the derivative of the function. Sine, you get cos x. In this trigo, you should multiply by differentiate again the variable of x here. So differentiate x, you get 1. So the derivative of the function is cos x, is still the same. But if you are given y equals to sine, let's say sine 3x, to differentiate the function by finding the derivative, sine, you know that you're going to get cos 3x, but you have to multiply again on what you have here. It means that to differentiate the 3x, you're going to get 3 here. So the answer would be 3 cos 3x. So since in this given function, it would be the cos 2x. So to differentiate the function, cos, you know that you're going to get negative sign. And the given function is 2x. So 2x here. You have to multiply again by differentiate back these 2x. So you get 2. So this would be the derivative of the cos 2x, negative sine 2x. Clear? Am I answer your question? Is it okay? So whenever you want to integrate the trigo, don't forget to differentiate back on the functions, the given functions next to this trigo. So if it's a variable of x, it doesn't have a problem because you get a value of 1. But if it is the other variable, then you have to differentiate. The same goes on, let's say, you need to differentiate you're given y equals to tangent 4x. If you want to find the derivative of the function, you know that if you differentiate tangent, you're going to get secant square. Secant square what? The given function here is 4x. Okay, you get secant square for x, then you have to multiply by, you need to differentiate back this 4x. Differentiate 4x, you get 4. So the derivative of the function become 4 secant square 4x. So this one is applied, the same things, the same method that you're going to apply with this one. So differentiate cos to x, you're going to get negative sine to x multiplied by 2. So the answer would be negative 2 sine to x. Okay, back to our main question. The next one would be, we want to we transform from the functions of fx dx into the function, integrate the functions fu du. So now you can see that to make your integrations much more easier, I'm going to bring negative 1 over 2 outside from the integration. So we have here negative 1 over 2 integrate u to the power of 3 du. And you can see here that it will be much more easier for you to integrate, and you can integrate the function directly. So integrate 1 over 3 here would be, integrate u to the power of 3. You're going to get u to the power of 4 over 4. And since this is indefinite integral, so you add up with the constant c. And then take out 1 over 4 outside from the integration. You have negative 1 over 8 u to the power of 4 plus c. And then the last one, replace back the u that you have let before this, which is the cos 2x minus 1. So we have negative 1 over 8. U will be cos 2x minus 1 to the power of 4 plus c. So this will be the answer. Right, is it clear on how we solve this question? Integrate sine 2x cos 2x minus 1 power of 3 dx.
If dx means du,
in this case, dx is not the du. Sine 2x dx is negative du over 2. You cannot just transform dx as the du. You have to rearrange from the derivative that you get so that you can replace back the function in terms of fu du. From the
3 cos 3x.
Sorry?
So what about the 3 cos 3x?
This one.
Yes. 3
This one?
3 cos 3x. 3 cos 3x. For B
Take off.
section.
Take off the 3x.
3 cos 3x for section B.
Section B.
Section
Which one?
B. I mean sine 2x bracket square 3
Me.
cos 2x minus 1 dx.
Is it here?
I mean, where's the usage of 3 cos 3x for the
Why?
third step of the section 3, section B? Yes,
This one.
yes.
No, this one, I'm showing to you the example how you differentiate the function, because at just now someone asking me where you get these two. How do you get these two? So I'm showing the example on how you want to differentiate a trigo. I just said just now, if you have a function of sine x, when you want to find the derivative, if you have sine, if differentiate sine, you're going to get cos. Okay, when you are given sine x, so the derivative would be cos x. But to differentiate the function, don't forget to differentiate again a function next to this trigo, which is differentiate x, you get 1. And the other situation would be if you have a function of sine 3x, how you want to differentiate the function? Again, differentiate sine, you get cos 3x. And the given function is differentiate sine, you get cos. And followed by the given function 3x, which is here 3x. And don't forget to differentiate again the 3x, which is you get 3. So the derivative of the function would be 3. We write down to the front. So the derivative of the function becomes 3 cos 3x. This is the example that I show on how you differentiate the trigo, which is the given function is not only x, but it can be 3x. And same on this question, it would be the 2x. The example how to differentiate the function, so that you are not confused where you get these two here. Is it clear?
Yes, it is.
All right, can I proceed with the next question?
Just proceed it, miss. It's okay.
Okay. All right, I'm going to move on the next question. We have settled on question 1, 2, 3. Next, we move on question number 4. Okay, let's say you are not given a variable of x. To integrate the function, it's not necessary to have a variable of x. You can have the other variables such as t, such as theta, so on and so forth. So let's say you have this integration. You need to integrate theta minus 2 to the power of 3 d theta. So looking on these questions, you also know that you cannot integrate this function directly. You have to apply the integrations by substitution to solve it. So as I said, the first step, whenever you want to integrate, step number 1, we're gonna let a u. So what would be the u that you're gonna let in this function? You have two options. This is either theta or theta minus 2. And as I said, normally the u that you want to let would be a function that is consist in the bracket. So it should be here, theta minus 2. So we let u equals to theta minus 2. And then we differentiate the function, getting du over d theta. Differentiate theta, you're going to get 1. Differentiate negative 2, you're going to get 0. So you have here du over d theta is equals to 1. The next step would be I'm going to bring d theta on the right side so that you get du equals to d theta. Okay, and then the next step would be, so now step number 1, I'm include together with step number 2, which is step number 2, you should find the d theta. So rearrange, you know that the d theta would be equals to du. This is on step number 2. Step number 3 would be you're going to replace back the integration from theta d theta into the integration of u du, so which is integration theta minus 2 to the power of 3 d theta, transform it into the ufu, so integration of, okay, now here first step, I'm going to replace first this one because you already know theta I still remain here. the theta minus u, theta minus 2, you have let as a u. So we have u to the power of 3. D theta is du. So we're still pending on theta here. And to rearrange it, make it theta as a term from the u that you have let. Bring the -2 on the right side. So you have here theta equals to u plus 2. So rearrange back from this integration, it become integrate u plus 2 multiplied by u to the power of 3 u. The next step will be expand the function. U multiplied by u to the power of 3. U here is u to the power of 1. So it become integrate u to the power of 4. The base is u, is the same. So the powers just add up the power 1 plus 3, you get the power of 4. Plus with 2u to the power of 3 du. And now you have transformed the complicated function into the simple one. The next step would be, we're going to move on step number 4, just integrate the function. So integrate u to the power of 4, you're going to get u to the power of 5 over 5, plus integrate 2u to the power of 3, you're going to get 2u to the power of 4 over 4. And since this is the indeterminate integral, add up with the constancy. And on step number 5 would be, you're going to replace back the u with theta minus 2 that you have let. So it should be theta minus 2 to the power of 5 over 5 plus 2 theta minus 2 to the power of 4 over 4. This one you can simplify, 2 over 4. You just simplify.
Excuse me.
Yeah.
This session is already finished. It's
11:30.
Yes, 11:30.
Yeah. I just finished up this question, and then I'm gonna wrap up on our topic. Can I?
Yes.
Okay. So the final answer would be, you're gonna replace back the u, and this would be the answer for this question. All right, so since the time it should be ended here, I just wrap up on what are the things that you should know in integration by parts lah. It's actually I have another one. I'm going to show to you the integration itself. What I'm showing to you just now would be the indefinite integral. There would be another method that would be definite integral, which is you have a limit on that function. But just a little bit explanation on this one. The process is still the same for indefinite integral, but then you have a limit. So to solve this one, the process would be, once you have integrated the function, you're going to replace back the x, and to get the value, you just substitute upper limit minus with lower limit, and then you're going to get the answer. So if you have the definite integral, which is you get the limit on the given function, it means that the process is still the same, doing like the integrations by substitution, but then it just consists of the limit. So to solve it, you just do the same process. We have 5 steps. Step number 1, let u, and then differentiate the function, substitute back into the function, replace the u with the x, and then substitute the value. All right, so to end our session time, I just want to conclude back on what you should know in integration by substitution. As I said, by using this integration is actually you transform the function from the complicated one, which is to the simpler one. So by applying these techniques, there would be much more easy for you to integrate the function, and you can integrate the function directly. And these techniques will help you to integrate the function easier compared to when you look on the first impression, you will think that it's too difficult for you to integrate. By using this substitution method, it helps you much more easy for you to integrate. So that would be the end sessions of our sharing sessions today. Thank you.
Thank you very much, Ibu Dr. Anisah Abdul Rahman, for your sharing for our student.
I'm sure. Sorry, Pak Vikara, someone was asking me. I'm giving the notes to your lecturer, and you can take the notes from your lecturer.
Okay, thank you very much.
Yeah.
Terima kasih banyak Ibu Anisah bin Abdul Rahman atas sharingnya ke mahasiswa kami Bina Sentara. Ibu Ajeng, ada yang mau disampaikan? Bu Ajeng Wulandari.
There's nothing from me actually, Pak Wikarya. Maybe before the end of the session, we can have group photo.
Saya mohon maaf,
Dr. Anisah.
Yeah, sure.
Videonya nggak bisa, ada gangguan, jadi nggak bisa keluar fotonya. Jadi kalau saya klik on-nya, keluarnya hanya background-nya aja.
Tak ada gambar, but it's okay.
Yes,
We can take whoever can turn on the camera, we can take.
Yeah.
We can take the picture. No problem at all.
I'm very sorry.
Okay. Participants, please turn on your camera so we can have group photo session with Dr. Anisah.
Ya, silakan dibuka kameranya supaya saya ada kerusakan, jadi ada gangguan, jadi nggak bisa foto. Baru kemarin gangguannya.
Apa Bapak bisa potret dengan telepon genggam Bapak sendiri?
Iya, Saudari Galdi Bari. Anda paling banyak nanya tadi ya. Ya, Ibu ya. Banyak bertanya terus.
Yeah, we'll start taking the picture. 1, 2, 3. Okay, and then the next page. 1, 2, 3. Okay, I've already take the picture. Thank you all. Thank you, Dr. Anisah.
Okay, no problem.
Give back to Pak Wikarya for the Q&A session.
Jangan lupa ada absennya ya. Absennya ada dicek ya, silakan. Saya ada kirim juga melalui WA grup masing-masing dan melalui Pak Tri Mudianto juga. Terima kasih banyak Ibu Anisah yang telah bersedia men-sharingkan ilmunya ke mahasiswa kami gitu.
Ya, harap dapat paham sedikitnya Pak Wikarya. Sorry if some of you are not so understanding on this method. But actually, integration by substitution, you have to practice, that you can understand better which one that you can choose. Alright, so saya undur diri dulu ya. Terima kasih.
Sampai jumpa. See you next time.
Alright, thank you everyone. Alright, bye.
Bye.
Thank you, Miss. Thank you, sir.
Terima
kasih banyak.
Terima kasih Pak, terima kasih Bu.
Sama-sama.
Terima kasih ya Bapak, and thank you Miss for the presentation.
Nah, ini baru hari ini saya lihat wajah Anda, Garibaldi. Garawadi ini pria atau wanita nih?
Ya pria, Bapak.
Oh, suara Anda kok kayak suara wanita gitu. Oh ya, Ibu Ajeng nanti sertifikat untuk Ibu Anisanya langsung dari Ibu Ajeng gitu, kirim ke sana.
Iya, nanti dari kita yang ngurusin, Pak. Kita sama
Oh ya, oke,
tim
makasih.
divisi. Ya.
Baik, terima kasih. Ya, jangan lupa mahasiswa ya, lihat kalau hari ini enggak bisa, saya udah kirim juga di WA group masing-masing, termasuk ke Pak Tribundianto, kelas data science yang lain, saya sudah kirim ke Pak Trinya.
Apa itu, Bapak?
Ya, Saudara Garibaldi,
Apa itu yang Bapak maksud? Yang untuk
absence, maksudnya kehadiran Anda, ya, kehadiran Anda bisa diisi pada form Google Form yang kami kirim
sudah?
ke WA group, ya.
Oh, ya maksudnya
Hari ini
itu
juga ada di ini sebenarnya, ada di cek, ada juga.
chat. Saya sudah akses
Ya,
dan
kalau sudah absen ya
sudah mengisi.
sudah. Iya, iya. Oke, jadi saya lihat tadi yang hadir sekitar 98 termasuk kita. Jadi ada 95 mahasiswa di Bu Ajeng. Itu gabungan dari 2 kelas saya tambah 1 kelas Pak Tribundianto gitu. Data Science ada 2 kelas, matematik statistik gabung kan di satu kelas itu. 70 mahasiswa plus data science yang ke saya ada 66 orang, kemudian dari Pak Tri ada berapa lagi, totalnya dari 98 kurang 3 ya. Saya dikurang sama Ibu Anisah sama Ibu Ajeng, jadi 95 mahasiswa totalnya. Lumayan ya, Bu Be. Ya, Bu Ajeng.
Iya, Pak. Iya, Pak.
Kehadirannya
Terima kasih
lumayan
banyak
baik.
ya, Pak Wi,
Ya.
udah
Saya
dibantuin.
juga
Terima kasih juga, Pak Tri.
Yang sangat mengecewakan itu dari LSC-nya terlambat sekali ya menghidupkannya.
Iya, Pak. Kalau hari Sabtu tuh kita
Sabtu.
suka kewalahan, padahal setengah jam
Wah,
sebelum
jadi
kita udah
repot juga
ingetin.
ya. Lain kali kalau
Iya.
Sabtu minta Ibu itu aja, Ibu apa? Kartika
Kartika.
Sari. Lebih
Oh
aman.
iya, Pak.
Itu lebih aman menurut saya.
Iya,
Saya
Pak.
agak baru lihat hari ini saya agak kecewa, jadi saya telepon Ibu Rena. Pas saya
Oh,
telepon
iya.
sudah mau sampaikan nyala. Jadi udah terlambat 13 menit tadi.
Iya, Pak.
Jadi kita merasa enak kan dengan tamu,
Dengan
peserta tamu gitu.
partnernya.
Ya, partnernya gitu. Ya,
Pak.
Bu. Ibu Ajeng jangan lupa ya mintakan dari LC
Recordingnya tadi ya.
link dari recordingnya supaya saya
Iya.
bisa upload ke YouTube, bisa share ke mahasiswa ya.
Ya,
Semua
baik,
mahasiswa
Pak.
yang hadir.
Ya.
Oke, terima kasih Ibu Ajeng.
Ya, terima kasih, Pak Wi.
Ya, sampai jumpa di Senin.
Terima kasih Pak Wi.
Terima kasih Pak Tribundianto ya. Terima kasih.
Terima kasih, Pak.
Ya, nanti link dari YouTube-nya akan saya kirim ke Pak Tri juga.
Iya,
Oke.
terima kasih.
Baiklah Bapak, terima kasih.
Ya, izin live.
Ya, terima kasih. Sama-sama. Saya izin live juga.
Oke, teman-teman, saya izin untuk end meeting-nya ya. Terima kasih semuanya.
Yo.